Hello, Sophie. This is Miss Lisa. This is the Math 5 for Sophie for Monday, April the 6th. You're going to be working on Chapter 16, which is ratios and proportions, and changing decimals to fractions and so forth, back and forth. I am sending you a copy of this paper, which will show you how to do proportions and ratios and just some tips on how to do that. So what you're going to work on this week is page 364 to 376. So what we're going to do is we're starting on page 365. We're talking about ratios. A ratio is a comparison of two quantities, and they can be written in three different forms. You can write it as a word form, you can write it as a fraction, or you can write it as a ratio. So if you look at the table at the top of 365, it shows you the three ways they do it. If you are writing it in a ratio form, you're going to use a colon to separate the numbers. Okay, so, okay. All right, so ratios can describe, ratios mathematically describe a situation. As for example, they have cats to dogs. There's a ratio of 2 cats for every 3 dogs. That means there's 2 cats, 3 dogs, 2 cats, 3 dogs. So that means that there are 2 cats for every 3 dogs that there are. Okay, so you're going to be working on 365 and 366, and those will be the ratios for that section. So I don't think you'll really have any problems there because that's pretty simple. Okay, so then we'll flip on over to equivalent ratios. So that is 367 and 368. So equivalent means they're equal to each other, right? So equivalent ratios are ratios. My eyes, I can't see really good here. Let me turn my other light on here. So, too much light. So equivalent ratios describe the same relationship in higher terms or in lower terms. Okay, so let me get my things situated here. That's better. Okay, and I can turn my lamp on here to where I can see a little better. There we go. Is that better now, I think? All right. So, all right. So, Mom plans to make her salad twice as large for the church potluck dinner. So twice as large means it's 2 times the size that she normally made it. So you would multiply to make a ratio in higher terms. So she would say, okay, if she had oranges to apples, if she usually used 2 oranges and 4 apples, then you multiply both by 2. So she would use 4 oranges and 8 apples. So the ratio of 2 to 4 is now 4 to 8. So if she wanted to make her salad half as large, that means she's cutting it in half of what she usually used, you would divide it to make the ratio in lower terms. Does that make sense? Okay, so an equation that shows the equivalent ratios is called a proportion. So if you had 2 to 4, that's the same thing as 1 to 2 if you cut it in half. 2 to 4 is the same as 4 to 8 if you doubled it. So those are equivalent fractions. If you had 4 to 9 and 2 to 3, that would not be an equivalent proportion because if you doubled the 4, you're not going to get, or if you divided the 4, you would get 2, but if you divided the 9, you would not get 3. Okay, so if they are equivalent to each other, just like when we reduce fractions, you know, if you had 4/8 and you reduced it, that would be 1/2, right? 3/6, you reduce that down to 1/3. Okay, so even though they're two different fractions, they still mean the same thing. They're equivalent to each other. It's just one is in lowest terms and the other is not. So if they are equivalent fractions and you put them together, then that is called a proportion. Okay, so on 368, you are following the table, red to blue, and you're going to decide whether they are proportions or not. Okay, so on 368, the big box there, a tessellation is a repeating pattern that has no gaps or overlaps. Tessellations fit together like a puzzle. These shapes, which are square, triangle, parallelogram, all fit together to make a tessellation. So if you took those pieces apart, you'd have triangles, squares, parallelograms. If you put them all together, then you would have the tessellation. It makes one big shape. Okay, so you're deciding there what's equivalent and what is not. Okay, any questions with that? Okay, all right, then we hop on over to 369 and 370, talking about map scales. Okay, so a map has a scale that tells you maybe like 1/2 inch is equivalent to a mile. Okay, so then you would use your ruler and measure, okay, how would I get from the house to the school? If that was 2 inches and each 1/2 inch was a mile, then you would add up those and you would end up with the right amount. So the green box on 369, a map scale gives a ratio comparing the size of a map and the size of an actual object. This map was made with a scale of 1 inch is 500 miles. Okay? So if 1 inch is 500 miles, then if you would look at the map, you see you've got the scale down there. And hold on just 1 second here. Let me get my, hang on just 1 second. All right, I'm back. All right, so a map scale, excuse me, a map scale, here they would show, they got the map of the United States. So they have going from Chicago, Illinois to Boise, Idaho is about 1,500 miles. If you took your ruler and you measured it, 1/2 inch is 250 miles, a whole inch is 500 miles. So you would add up that and you would come up with 1,500 miles. So they want you to complete the rest of that chart. And then you have, looks like a map of an airport. And they want you to come up with some measurements and ratios for those. Okay. So any questions there, you can ask me later. All righty. 371 and 372, rates. Okay. A rate is a special kind of a ratio. Okay. It distributes a quantity over time. So a unit rate tells how many of the quantity there are for each unit of another quantity. For example, Samuel is paid $24 for working 3 hours. What is Samuel's unit rate of pay per hour? So if he worked 24 hours, if he worked 3 hours and made $24, you want to find out how much did he make in 1 hour. So you would take 24 and divide it by 3. That would tell you he makes $8 an hour. So that is the unit rate of pay. So if you wanted to find out how much money he would get in 7 hours, well, you know he makes $8 an hour. So if you took the $8 times the 7 hours, that would give you $56. So that's what he would make for 7 hours of work. Okay, so we've got some example problems of those on page 371 and 372. You have some word problems to that effect on 372 at the bottom. So that should be pretty self-explanatory. And again, if you have any questions, you can ask me later on. All right, then we are on 373 and 374. Ratios and percents. Now remember, ratios was comparing two items to each other. Okay, so percents, you think of that when you are, say you get a test grade. I got a 90%. Okay, so you got 90% out of 100, right? If you go to the store and you want to buy something and it is 25% off, then you know you're saving 25% of the total cost. So a percent is also a type of ratio. Okay, that is where the quantity is compared to 100, and the sign for percent is the two circles with the line through it, like you have on the top of the number 5 on your keyboard. So you could write a percent as a fraction. Let's say something was 25% off, it would be 25 over 100, just like a fraction. Okay, let's see. So if you look at the box at the top of 373, Joanna took a written test that had 100 questions. She answered 91 of the questions correctly. So out of 100, she got 91 right, which means she got a 91%, which is very good. So each of those squares there represents one of the questions. So she's got 91 green squares and the 9 white squares, which shows you 91 of 100 or 91%. So you are going to write the ratios they have given you as percents. So 40 over 100 is going to be 40%, right? 17 over 100 is 17%. So whatever number you write on the top and you have 100 on the bottom, the percent is going to be what's on the top because you're always taking it out of 100. Okay? When you get to 7 to 15, you're doing the opposite. They say, what is 5%? Well, the 5 goes on top, then the bottom of your fraction is 100. Okay? Then at the bottom, you've got another colored square. It's got brown and green and white and pink. So it's talking about 100 students and the ice cream flavors that they prefer. So the 100 squares there shows how many students preferred each flavor. You had chocolate, vanilla, mint chocolate chip, which is the green, and the strawberry. So they gave you either a ratio or a percent, and you want to give me the other to complete that. Okay, 374. Equivalent ratios are, and percents describe the same relationship. Okay, just like a proportion, they are equivalent to each other. So an equivalent ratio and a percent are describing the same thing. Okay, so if we are changing a percent, if we change a ratio to a percent, okay, we're going to work on that one first. So let's look at the top of 374. Mrs. Fitzgerald has 12 boys in her 5th grade class. Since the class contains 20 students, the ratio of boys to the students is 12 to 20. So what percent of the students are boys? Well, 12 boys out of 20, okay, which is equivalent to 7 out of 100. Okay, so let me see here. All right. Okay, 12 times 5. Okay, they multiply the top and the bottom by 5. So 12 times 5 is 60, 20 times 5 is 100. So that tells you 60% of the class is boys. Okay, let me see here. Okay, let me check something here. The ratio. Okay, so you're going to use on my little sheet that I'm sending you to email by email. It's going to have a little box that says percent ratios. So you're going to have, we had the 12 over 20, then you would equal some percent over 100, okay? So that's how we're gonna, how they figured that out, okay? So if I had an example, what was 60% of 90? You would have x over 90 is 60 over 100. Okay, and so then the x would tell you how much that would be. Okay, so I mean it's a little confusing at first, but I'm sure that you can handle it. So let me see here. So the way you have to do it is you have to set up a proportion. Okay, so changing a ratio to a percent or changing a percent to a ratio, you have to have a proportion for that, okay? So if you had, Jeremy answered 18 questions correctly on a 20-question quiz. So what percent would his quiz grade be? Okay, let me see if I can find. I'm not sure if I can. I want to see if I can pull up my whiteboard. No, not that one. Let's see. No, I don't think that's going to work. No. Okay. Close that back out. Let me see here. So, all right, he has 18 out of 20 questions correct. So your fraction is going to be 18 over 20. Let me try something here. So 18 over 20. So that would be your, if you can see that, that would be your first thing right there. So he's got 18 questions correct out of 20. Okay, so we want to know what grade he got. All right, so we've got the fraction form of the ratio answered. Okay, so that's 18 over 20. So then you're going to set up a proportion. Okay, so what we'll just say we'll multiply by 5. Okay, so this is what you're going to look at, and this is what it's going to look like. Okay, so 5 times 5. So we're making an equivalent fraction to the 18 out of 20. But we're going to put it, we have the bottom number has to equal 100. That's why you're multiplying by 5 because the bottom number is 20, so you want to get 100. So then 18 times 5, 8 times 5 is 40, 590, okay? So you multiply that out, and that tells you what his grade would be. Pull this up so you can see it a little better, maybe. Okay, so if you multiply that out, you would see that 18 out of 20 is 90%. Okay, so that's how you would change a ratio to a percent. All right, so now if we wanted to do it the opposite way, and you want to change a percent to a ratio, then that's the second green box on 374. If 60% of the students are boys, then 40% of the students are girls, right? So what ratio of the students are girls? So you know girls equals 40%, correct? So that is 40 out of 100. So this tells you right here, let me get it right place where you can actually see it. That tells you that 40% of the class are girls, okay? So if I want to change that, I'm going to divide by 20 so that I can get it basically kind of to lowest terms. Okay, so 100 divided by 20 is 5. 40 by 20 is 2. So 2/5 of the class are girls. So that's what that's going to look like. Okay, so if you're changing from a ratio to a percent, you want to multiply by an equivalent fraction. Okay, by like multiply by 5, whatever you got to get to 100 on the bottom. When you are changing from a percent to a ratio, you want to make sure that you end up with, you start out with 100 on the bottom, so you're going to divide by 20 to get 5 on the bottom. All right. So let me see here. Let me see. 8. Okay. Any questions on that you can ask. All right, so I think that should be, it's kind of confusing at the beginning, but once you get working with it a little bit, it's not too awful bad. All right, then the last section is decimals and percents. So 375 and 376. All right, so a decimal, we know what decimal points are, right? Okay, so a percent is a ratio where the quantities compare to 100, right? So 75% would be 75 over 100 if you write it as a fraction. If you want to put it as a decimal, it would be 0.75, which is 75 hundredths because it's 75 out of 100. Okay. Percents can also be used to name one whole. 100% is 100 over 100 or 1.0. If a decimal has hundredths in its name, then you can replace the term with percent when describing part of one whole. So the fraction or the decimal there at the bottom, 0.09, that's 9% because that's 9 hundredths, because the 9 is in the hundredths place. 0.14 is 14 hundredths because the 4 ends up in the hundredths place. Okay, they've got a fraction there. 3/4 is the same thing as 75 out of 100, which is 0.75 or 75%. Okay, 1 through 3, they gave you the little grid, and you're going to write the fraction form and write the percent form. So number 1, they've got 0.35. There are 35 blocks filled in out of that 100. So then your fraction is going to be 35 out of 100, right? Which equals 35%. Okay. Down in the blue box, changing a fraction to a decimal in order to find the percent. So the way you do that, you've got 3/5 equals 3 divided by 5, correct? So you would just do a normal division problem, okay? And then you just round your answer out. So that ends up being 0.6, which would be 60%. If you want to change a percent to a fraction in order to find the decimal, you're going to rename the percent as a fraction. For example, they give you 32%, which is 32 over 100. So you write that as a decimal, 0.32. That's 32%. Okay, so that's what we are doing for that section. Okay, so when you get a chance to do the test for chapter 12, just go ahead and scan it in, or have mom take a picture of it, or you can take a picture of it and just email it to me. That's fine. And then once you work on these, then next week we'll finish chapter 13, and we will go from there. So we're still talking about percents and so forth. So if you have any questions, you know, you can call me or email me. I do have your email address, and I will keep in touch with you. And once I grade your Story of the World tests, I'll send those out to you by email too. I'm sure you did fine. And we will see you next week. And I will upload the Story of the World video for you also. It's going to be on YouTube. And this math video will be on YouTube also. So I will talk to you next week. All right. See you later. Bye.